Hi everyone, I'm Bruno Aziza and welcome to a great panel on the lake house today. I'm excited because we have customers of different industries, different maturity, and we're going to talk about the motivation around the lake house, but more importantly, we're going to learn about how they think about it and how they deploy it. This panel today is short, and so the intention today is to create a conversation with the community. We want to encourage you to reach out to those leaders after this so you can continue the conversation. If you think you've got lessons you can share with them, please do so. And if you think you like what they said today, make sure to follow up with them and get more details. So we've got a very interesting panel. I'm going to start with a simple question for everyone so they can get to introduce themselves, but also give you their perspective on the concept of the lake house. So let's start with this first basic question. What are the most important motivations to building a lake house? And I'm going to start with you, Bo and Chip, from Snap. So tell us about the company and tell us about your motivation.
Okay. My name is Bo. I'm a senior engineering manager for data infrastructure here at Snapchat. Snap's a really interesting company. It's a company with over 300 million DAU and growing. And also we have a large data scale. What kind of scale am I talking about? At any given day, we're collecting around 1.3 to 1.5 trillion events across all the user base. That translates to roughly just over 2 petabytes of data ingested per day, net new data. And then on the other side, into our warehouse, we have roughly just under 100 petabytes read out of data warehouse on a daily basis. Why is this a problem? If you think about it from the motivation to the lake house, all this data needs to be governed. And governing the data is very difficult, particularly when different users access the data, and then different users have different requirements for kind of storing the data as well. What we saw happening was that across the company, as Snap matured, there was a proliferation of different technology to solve this problem. And different teams across the company will create their different data policy solutions, the way that we phrased it. And this created a lot of problems around economies of scale. It became more and more difficult to govern actually, because the security team at Snapchat is not a very large team. They work directly with infrastructure, and their mandate to us was you have to govern all this data. You have to store it in a way that's compliant, and we can't solve this problem across all their different teams. You have to solve it in a centralized kind of fashion, and that was what started this kind of motivation for the lake house.
So this is really interesting, right, Chip? And I know you guys are working together. Often people think about the lake house as the convergence of workloads, but there's another dimension here, and we'll get to talk about this in a little bit, around security, performance, and governance. What is your take, Chip, on what Bo just talked about here?
Hey, my name is Ciprian Gera, and I'm senior staff engineer with Snap. And I wanted to say that for me, when I joined Snap, I used to work at Meta before Snap, and Meta has basically that's all they have is one giant lake house. And joining Snap, I was looking around and I couldn't understand why people didn't build that already. And obviously now we understand that the path of least resistance is for people to just dump some data into the cloud storage and then figure out how to process it. But for a while, I kept looking for where is your lake house, and once I realized that it's not there, I knew that we were going to have to build one.
So you've evolved, Kevin, in the world where the lake house was essentially the only thing you knew. So it felt weird that you'd have to make the decision to have one. So that's an interesting perspective. Now, Richard, you work in a company that is brand new, where you might not have had to deal with the past that Bo and Chip just talked about. How did you think about the lake house?
Yes, I'm Richard Archer, a staff data engineer at Wizard. Wizard's a conversational commerce company. We're focusing on allowing users to purchase and discover products via chat. And so we really were starting from scratch. We're barely a year old. So when we're thinking about the lake house, we're really thinking about how do we quickly get to a point where we can query large volumes of data, both structured and semi-structured. We have a lot of text-based conversational data. It's relatively semi-structured, and really being able to query that in a structured manner, and really being able to provide that insight to specifically our AI and ML team as we develop that technology is really critical for us.
That's excellent. And how big is your team? Do you need a large team to start a lakehouse?
we really don't need that large of a team. I mean, there's about 3 or 4 of us on the data engineering team, and we have just more than that on the AI/ML team. So we're a small team that's supporting much larger teams, and really the Lakehouse architecture allows us to support those much larger teams than us.
All right, so for you, it's an element of scale and the ability to get going very fast. Now, on your side, Scott, different industry, financial services. You, of course, have a long history of managing data at scale. So tell us a little bit about yourself and tell us a little bit about how you think about the Lakehouse.
Sure. So I'm Scott Conant. I'm the risk CTO at Deutsche, and primarily what I look after is an application called Risk Finder, which does the bank-wide risk and capital metric calculation. So we do an awful lot of compute, generating a lot of structured data, and that goes through primary processes. So we have to dish out data daily to regulators. We use it internally for risk management, for capital and product optimization. But also, this is a vast array of data which we don't particularly leverage well. We are running all of this stuff at scale. We're doing the daily processes across the bank, which is great. Lakehouse is really one of the areas we're exploring to get us to the next stage. How do we get all of the data and all of the ancillary process together? And what happens in banks typically is that you build lots of different applications with lots of teams all over the place because it's an easy way to get SLAs. It's an easy way to get guaranteed data governance in a particular area. But we need to get that out. We can do more with our data, provide more access to the end users who need it. So Lakehouse is potentially a big plank in that for us. How do we do that without simply replicating an extensive, decades-long software build to get to where we were?
And this is part of also how you're modernizing your approach, moving from systems on-prem to systems in the cloud and a hybrid world as well. So the Lakehouse means a lot more than just unifying workloads for you. You mentioned risk here, and this is a topic that we started talking about around governance and security. And I want to come back to this, Bo and Chip, on when you think about securing and governance and performant, Lakehouse, what are the key principles you're applying? And how does BigLake kind of help you kind of implement these key principles?
Yeah, I can kick it off, Chip, and then you can remind me of anything I forgot during our fun journey building this out. I think one of the interesting things was I remember having this distinct one-on-one with the head of security at Snap, and he basically told me what keeps him up at night is not knowing what the schema in our GCS data is, and that there's no way to govern it because when we have to be compliant for deletion, when the data is in BigQuery, it's schematized, so we know what to delete, what columns to drop, etc. But when it comes to GCS data, it becomes pretty daunting. You have to kind of know the schema ahead of time. And again, just to reference, teams across Snapchat build their own data puddles. They have their own schema. It baked into the code effectively, and they had their own formats. So that's one angle of it. That's the second angle about the governance side was having another one-on-one with finance. And finance's biggest concern was, look, we can try and make security satisfied with the government data, but it's going to cost a lot of money. So how do you do this very efficiently to kind of drop columns, delete rows, etc. So when I think about what does it mean to build a secure, government, performant data lake, is can we take all the data, put it into one location, make sure that by default out of the box, any regulatory policies like GDPR compliance are just kind of built into the feature itself, so we don't really have to rebuild those rules. And secondly, when you apply those rules on top, is the Lakehouse or BigLake do it at the most cost-effective manner from a scaling perspective? So per byte ingested in, is everything getting deleted and being dropped at a most cost-efficient manner? So if that problem is solved, yeah, I think that's the gold at the end of the rainbow, so to speak, right?
Yeah, so I would like to add something about that. I would like to add something about just so that people understand the difficulty of that is basically we used to keep data in Google Cloud Storage, and Google Cloud Storage basically consists of buckets, and the buckets have files. And it is actually very difficult to understand not only what the schema I have, but what data sets you have. Like, is this bucket, does it contain one logical data set, several logical data sets, how you partition it, so there's basically no order in that. And one of the, our security team would spend a lot of brain power trying to answer this question of, what data do we have in Google Cloud Storage? So, and after that, obviously, you have to apply all these policies and scalable deletion and so on. That is one angle. And the other angle, relative to performance, I will say a few words about that is we are basically mostly a Google shop when it comes to analytics. And so we also have a data warehouse, which is built on BigQuery, which is an amazing product. And when we look at the performance, what we would like to have is the close to BigQuery performance on this data that is in data lake, and that is something that we're still working on, and Google is working on. I hear a lot of good things are coming in that direction, but this our users would require that. For many reasons, they do not want to keep data in BigQuery. It's not appropriate in all situations, and so what we have done until now is to basically try to do all sorts of hand-rolled versions of things that would be easier and better done by BigQuery. And I'm hoping that BigQuery will come to the rescue in this area with BigLake.
So I love how you're talking about puddles, Bo, as it relates to the analogy of the lake house, because you're dealing with highly empowered organization, of course, and highly mature. And I love, Chip, how you kind of brought up this idea that, of course, it's more than just unification. And there's a lot of depth functionality that you're requiring in order to make this work at scale. We talked about security, but here performance is a big one, which brings me to the other topic of there's a lot of formats out there, right? There's a lot of new innovation going out. Iceberg is a nascent format that's very popular in the industry. And I know that in this panel, people have different perspectives around Iceberg. And so I want to talk a little bit about that. And I'm going to start with you, Richard. We see Iceberg, of course, is an emerging, is a preferred format for lots of customers that are looking to build this open lakehouse architecture. Is this on top of your consideration list? How do you think about Iceberg in relationship to everything else? And then I'd like to see how people agree or disagree with Richard's perspective. I'm going to put you in the hot seat, Richard.
Sure. So we're very committed to open file formats and open source. So we're really heavily focused on Parquet right now, and we're looking to move to Iceberg hopefully in Q4 here. So one of the big things that unlocks for us is the schema evolutions and the transactional nature of that format. We are a young company. The schemas that we have for all the application sides are evolving very rapidly. So being able to leverage the Iceberg format for the data lake is going to be critical for us as we continue to grow and scale the company. So the transactional format, as well as some of the data snapshotting, will continue to be really important for us as a feature. And that's why we're looking to move to Iceberg in Q4.
All right, snapshotting and lots of great features around schema evolution. So Chip, what do you think about what Richard just said here? What's your perspective on Iceberg?
Yes, so we have been looking at Iceberg and actually working on it for more than a year now. And I think what you will also discover is that it is almost impossible to scale to large schemas, meaning tables that have a large number of columns, which is very often what happens with the machine learning data, or tables that have a long history, which is also something you need for machine learning, or where you have lots of partitions for whatever reason. And so I think you will be pleased with Iceberg on that regard. It will deliver a lot better than the old Hive style metadata format.
That's excellent. So that's definitely something I would say around this panel you would suggest people look into and put to the top of their consideration list, it sounds like, huh? Lots of innovation going on there. Anything else in the space that you find is interesting as it relates to the format? I mean, Richard talked about Parquet, of course, but anything else that gets your attention and when you're kind of comparing and contrasting?
I'll double down on the size kind of call out. One of the key criteria, one of the tables, the machine learning data sets was about 20 petabytes in size. And if you think about kind of loading that data up and trying to play around with it, it's pretty significant. And Iceberg really kind of came to the rescue in that sense.
That's excellent. All right. Well, I want to continue on this conversation on, how you now take the data lake and make it real in terms of outcomes for your organization. We talked a lot about the technology and the architecture considerations, and now we want to think about, okay, how do we create value for our organization with this new architecture? So, Scott, I want to turn to you in terms of how you're thinking about the journey that you've been on so far. Traditional industry, lots and lots of data, huge history compared to the other organizations that are younger than yours. And how do you think about the outcomes of this architecture for your company, the industry, and maybe for everybody else to think about? How should they think about this?
Yeah, well, I mean, apart from the jealousy, obviously, at not having all of the legacy estate to worry about, which is great. But actually, a lot of the themes are quite similar, and particularly echo, some of the aspects Bo and Chip were saying. For us, the value is effectively, what are we going to get from investing into our platform, re-architecting, and actually doing work to move stuff into a new mode of operation. Now, a lot of the stuff that we've talked about, we obviously want to get benefits and performance in not having to build componentry to do basic stuff. And the application we have is called Risk Finder, and part of the reason, well, you might even say that the answer is now, well, where is the risk? It's on, our data lake potentially. We will see. But part of it is about consolidating down. So we actually are putting all of the like business processes that should be together in one place, the outputs are known. And of course, the key to that is making sure that you don't end up with secondary proliferation after the fact. So if we put it on a data lake, but there isn't enough performance or there isn't enough flexibility, you don't have the power to do analyses, you end up creating secondary copies in places you don't know. Your attack surface is larger. You have no governance. Nobody even knows where to look when you're. So actually, this is kind of the key thing for us. The most interesting thing, of course, we are putting in open formats only. Of course, we need to keep a very close eye on performance. But really, what we're also interested in, can we make this work for use cases we don't even have, and avoid building lots of proprietary applications for doing historical and trending. Now, again, we are doing stuff for the entire bank across thousands of scenarios. So if you take, for example, the quantitative pricing that a trader might do for an intraday risk price, we're repeating that calculation across thousands historical market data sets, captured market data sets across multiple days, every day. So our data is quite dense and very, very structured, but also not particularly mined. Once we've produced the data for the day and we move on, a lot of it is just, aggregated and left in some backorder. This allows us to potentially change a lot more capability, and really it all comes together. Can we do all of that? It sounds almost like a magic bean. We could potentially do all of that while still retaining the governance, while still having the performance, and without proliferation. And this is why it's a big deal for us.
And there's also the notion of regulation and how you manage the data itself. I think, Bo, you had said earlier that you think about it as kind of a certified architecture in regulatory environments. You got to think about the compliance around the environment. So how do you think about that across all your guys' industries, actually?
Yeah, you can kind of imagine from a typical engineering team, right? If you're a feature team playing around with data and you've been asked to read up, from a legal standpoint, read up on the compliance aspect for different markets, not just the US, for example. Sounds like Scott is, in the EU, and so like there's a lot of kind of different aspects of that, and that's just not like a scalable approach, right? So when I think about across different industries, is that as these rules come out, as a commoditized solution like BigLake rolls out as well, like automatically kind of feeding any regulatory concerns on top of it is a huge value add, right? Because I just don't have to spend engineering like resources to solve essentially a compliance discussion, right? I'd rather have the engineering teams build real productivity value on top of data for other engineers, right? So that's the simple way that I think about it.
Yeah, and it's funny because when we think about the lakehouse from a technical standpoint, people tend to think about unification of data, all the data brought together. But in fact, quickly as we're discovered through this conversation, it's unification of workloads, unification of people and teams working together, and also kind of building capabilities that are enterprise capabilities so you can manage data at scale. You also talked about this idea of costs and management of the data, which are, typically we don't spend enough time talking about. So I hope people listening to us got value out of this conversation. Like I said at the beginning, this is meant to be a quick conversation and kind of connect you with the rest of the community. So we hope that people are going to reach out to you. Of course, you can click on the link down here to get access to all the other sessions at Google Next. But the one thing I want to invite everybody here to do is reach out to every single member of our panel to continue this conversation. And who knows, maybe you'll be in our next panel next time at the next event. So I want to thank every one of you. Thanks for taking the time today, and then we'll see you very soon.